All right, thank you for joining us today. What we're looking at is an X44 Kongsberg table. I've got a couple different materials to show you today. But first, let's talk a little bit about the head that we're looking at. The head that we're looking at is a multi-cut HP. I've got a rigid material knife in this tool position, a multi-purpose high frequency in this position, and then I've got a router over here. This is a 3 kilowatt router, so it is liquid cooled. Changing tools out is fairly simple. Push down on the lock here, tool comes out just like that. See, each tool does include a barcode, so that barcode indicates what tool this is and what calibrations it's going to reference. Putting a tool in, you're just following the cotter pin's alignment, pushing down on the lock, and then releasing the lock to secure it in position. Now with the router, as I mentioned, we do have liquid cooling. This is the extraction debris vac line. We've got our 2 coolant lines for the motor itself, and then I've got a lubrication line there if I had the lubrication option activated. Typically, you're only going to use the lubrication option if you're cutting aluminum or metals, but it does just a pretty good job at extending the bit life. Now, this line here that's coming down the front, that is an air line. That is a bit cooler. So we do put positive cool air on the bit itself, and that is a standard option for the machine. So the first material I've got for you here, this is a coroplast material, so plastic corrugate. These are your typical yard sign, political signage type materials. Very easy to cut. We're going to cut this with the rigid material knife. Now, unique thing about this job and why we like to show this is because traditionally, when you're cutting square rectangles, you cut around each 4 sides of each square. With IPC and our optimizations, we're able to do a single line cut down the center if all these squares are the same size and arranged with a 0 spacing. So let's watch how that runs. So first thing I'm going to do is I'm going to ensure that my vacuum bed is leveled at 0. So I'm going to come over and I'm going to 0 out the bed. And the reason that's important is because we can move from, an underlay system when we're routing to, the belt that's built into the machine. We don't want to mill into that belt because that belt is considered semi-permanent. It's not something you want to be replacing often. So I'm going to go ahead and start the job now. The machine is going to find that first registration mark, and we'll watch how it cuts down the side of the job. There we're finding that first registration mark, and then the machine goes and finds the rest of them automatically. And again, we're using a rigid material knife. So this is like a drag knife blade. There's that single cut across all 3 shapes. Start of a perimeter cut here. Then the machine's trying to find the best logic to cut through the job as quick as it can. Okay. So there's coroplast. I did have a couple of relief cuts in there so that my waist was just smaller. That off to the side. And then we'll take a look at the cuts here. So again, these were all individual jobs. There were, I think, 3 designs, nested 3 up, with a shared common cut line. Now that optimization is part of the normal configuration for IPC, so no extra cost associated with that technology. Again, that was a rigid material knife. I'm going to switch gears and we're going to cut some foam board now This foam board is going to be cut with that oscillating knife. So a multi-purpose high-frequency knife is what we're going to use to cut this. But we're also going to cut this from the backside. We're going to cut it blind. Now, what that entails is it entails an extra registration step to read the edge of the board. But it's very simple to convert any job into a backside cut with our IPC software. So real quickly, we're going to take a look at our IPC software while we're mentioning it. This is the main interface, the cut interface. The job interface is what this looks like, and this is where all your jobs are stored. You can see some of them do have estimations on their time, and that's due to the material and thickness is assigned and correctly set up for that job. Some of them here, you can see we've got no material associated with it. So the machine doesn't know how long to estimate because it doesn't know which tool you're going to use. Each tool can run at different speeds. The speed that we saw on the coroplast, that was full edge speeds of the machine. This job here is going to run a little bit slower, and that's just due to the vibration of that knife, the vertical Z movement of that blade. If I go too fast, I'm going to, like a rock skips on a pond, I'm going to kind of hop over and leave some uncut material in between, and we don't want that. So we've got to lower the speed to an appropriate speed so that we get a good cut. So let's take a look at this job specifically. And again, we want to run this from the backside. So IPC can take any job as long as it has registration marks and you know the material size, and we can convert this to a backside cut. So to convert that, you just click right there, and that little flip icon indicates that this job is going to run from the backside. So switch you over to the camera view where we can see everything, and we'll go ahead and start this job. So I'm going to hit start on control panel. Now, the first thing that the machine is going to want to know is where the corner of the material is. So if we look at our software screen, I'll kind of nudge the camera over so that it can find the corner. And that's indicated by that green triangle we see in that software screen. Yeah, that green triangle right there at that corner. I'm going to go ahead and confirm that corner. So I'm going to hit start. Machine is going to go and measure the thickness of my material. Again, we automate that value, that thickness value. And that's just due to, the variability of different thicknesses of material. Now the machine is looking for the registration mark. So it found the edge of the material and it called that a virtual zero. And then from that virtual zero, it wants to know how far away from that zero is the registration mark. Now the machine knows where the cut is in relation to that first corner we looked at. So when the machine is saying now, we look at the very bottom there, bottom left, it says flip the sheet in the X direction of the table. So we're going to go ahead and do that. I'm going to go ahead and push the machine back and clear my table space. I'm going to take the job, I'm going to flip it over. Again, X direction is front to back, Y is left to right. And we're going to put that right there. So I do have a pretty wicked angle on this. But this is, again, just to illustrate that the machine can accommodate for that poor placement on the bed. So that's not going to create any issues for us. So I'm going to go ahead and confirm that I've flipped. So I'm starting the machine, and now it's looking where it thinks that corner should be. But since I've got a funny angle on my placement, I'm going to go ahead and nudge the machine over so that I can show it where that corner is. So if we're looking at our software screen right there, you can see that the machine has found the corner. It accepts the angle that the corner is at by matching it. So I'm going to go ahead and confirm that. And then the machine is going to scan down the side and the top to get a more granular angle before it cuts. So there's our cut there. There's our first plunge in. And again, this is not running full speed. We're running at about 350 inches a minute. So again, a little bit slower. I've got a little bit more of a precision speed on my cut path. I can run this tool up to about 900 inches a minute, which is still not full speed of an edge. A full X can do this, at full speed if you're using what we call a standard reciprocating knife. That knife is what we're going to use a little bit later on our corrugate material. Again, this is a high frequency knife. So I've got a longer stroke, so there's more risk of it skipping like a stone on a pond. This is more for precision cutting. Foam board is what we're cutting here. And again, we're cutting it blind from the backside. Almost finished here. This is our last cut. Got a couple relief cuts there. Yep. Perfect. So again, we cut that from the backside, and note the extreme angle that I've placed the board on here. We'll go ahead and lift this up, and we'll look at our cuts. Everything's falling out quite nicely. And if we look at our bleeds here, you can see that the bleeds on the circular cuts very centered. And we'll take a peek at some of these cuts themselves. So I know people like to look at the round cuts. Foam is particularly challenging on round, contours like this. With our vibe knife, our oscillating knife, get some very nice contour cuts. And even our straight corner cuts, fantastic. Nice and sharp. No pilling or pulling of that center core. Even the backside. Nice crisp corners. So again, this is like 3/16 foam. Gilman's brand. HP printed this for us. So this is an HP latex ink. Foam core. All right, so I'm gonna switch gears a little bit on this. We're gonna change some tools, and we're gonna look at this corrugate. So this is true paper-based corrugate. I do have a white clay face sheet on this and some ink. This job is not printed for the cut that we're gonna use. This job is specifically just a standard box template that we're gonna cut out of this material. So I'm going to put 2 new tools in. So we'll back up here so you can see everything that's going on. All right. So I'm going to take out these tools. Again, this is the rigid material knife. We'll take a peek at the blade real quick. This is what I use to cut on the coroplast. So that plastic corrugate. It is an 8 mil round shank tungsten carbide. And then again, I'll show you what this one looks like. This is more heavier duty than the one that I'm about to put in. Again, we've got a longer stroke on this tool. And that's the blade that I was using on that foam core. So this oscillating tool has a shorter stroke, therefore I can go at full speed. Let's take a look at the blade tip that I'm using for the corrugate material. So it's a little bit more girthy of a blade, but stronger, so I can do those quick cuts on the contours of corrugate material at full speed. So again, I'm putting my tool down. This is a powered tool, so I do need to connect the power up here. And then I'm going to put my crease wheel. This is a medium-sized crease wheel. We're going to put this in. You can see the contour of the crease wheel right there. Probably a little too soft for our material, but I think it'll work for us. So we're going to put that in, and then I'm going to reach under and insert the crease wheel there. Now, so I've put new tools in, and we're going to start some cutting. Note that I'm not going to recalibrate any of these tools. So my initial calibration for these tools are to 0. So if I cut to 0 in my software, I should cut through the material completely. Sometimes if you want to bury it and go a little bit deeper, if you're going at full speed, that's possible. But this job is kind of specific for these type of tools. So let's take a look at how that is configured. So in our software screen here, we're going to go to our simple box. I'm just going to go continue on this. And you can see I've got a crease layer. I've got a copy of the crease layer using a tool that's going to put a perf wheel in it. So let's set this up. Here we're going to change this to reciprocating knife. And we're going to go 1180 for our edge speeds. This one again, reciprocating 1180. So here's inside the layer, the cut layer. I could do overcuts if I wanted. I could adjust my circle adjustment. And then I could do multiple passes if I so choose. And then this one, this is a copy of the crease. The reason I have this in here is this is a perf cut perforation pattern. I'm going to activate this so that I'm going to crease and I'm going to perf cut all of my folds. So I'm going to set my pit to 1/4 inch. That's how much material it's going to leave behind, and then how much material it's going to cut away is our land. Okay. So in my production tab here, I do have this job set up to edge recognition. So this is, again, a little bit different than what we saw on the last job where we're using registration marks. This job is not going to be using any registration marks. I'm going to use the edge of the material to align the cut to this. One last thing that I just want to double check is I want to double check my flute direction. So right here, I've got my flute direction front to back, and that's exactly how I want it. And that's going to be based on these pressure settings. So my crease is going to put 35% pressure with the flutes, and then 55% pressure against the flutes. So I can control those independently. So now that I've explained how this file is set up, let's go ahead and watch it run. I'm going to start the job. We're going to activate our vacuum for that particular vacuum zone. And then we are going to find the edge of the material. There on my bottom right software screen, you can see the little green triangle. I'm going to confirm the edge of the material. Again, the machine is going to measure the thickness of the material and automate in those tool up values and automatically calculate based on that thickness. If you're going to be running multiple depths, it also uses that little green foot to actually check that as well and confirm how many passes that multi-pass depth is going to have. So here we're in our first layer of production. This is the crease wheel. Now we're going to our perf cut. So you can see it going up and down on those perf lines. This layer takes probably about the longest just due to the speed and the vertical Z movements that the machine is taking. This is 100% not necessary also. This is just me demonstrating a feature within the software. By no means should you or do you need to put a perf cut in your crease layer. Also, a couple things to note. I do have a laser fence that goes across the front and the back of the machine. So if I get in here too close, you can see that the machine does go into a safety fault. I can just clear that safety, and then I can continue the job. So I haven't actually lost anything when that happens. Now we're on our last layer. This is the final perimeter cut. Now we're complete. So from this point, take a peek at what these cuts and creases look like. Again, the perf cut inside of here, 100% extra and not necessary. It's just me demonstrating that the software can quickly and easily convert a solid cut path into a perf cut path. So I'll quickly assemble this for you. This box was made from QuickBox. Our partner at ESCO can license QuickBox so that it's fully integrated and built into IPC for quick reference. There you go. See how nice that perf cut makes the corners. Makes them very sharp. So that was Corrugate, and that was our Corrugate tools. I do have another head that is specific for Corrugate production. The power head would effectively be similar, but it would have the two tools, no router. I'm going to have a heavy duty creasing wheel in that position, the router position. Speaking of routing, let's take a peek at the router and see what it can do. Again, I mentioned that we do have equipped on this machine a 3 kilowatt router. We also have an optional 1 kilowatt. The 1 kilowatt is not water cooled. It's air cooled only. So you do need to be considerate of how hard you push through material with the 1 kilowatt. The 3 kilowatt, we can run pretty hard through some of the more plasticky type materials. Anything metal related is you're going to have to go slow and multiple passes. But acrylics, PVCs, some of those kind of Delrin plastics, those type of materials, all can cut very well with this machine. I do have a 1.9 inch clearance under the beam. So the thickest material, I would recommend you cut is somewhere, at max 1.9, 1.95. I think it's a 2-inch beam clearance, something like that. But yeah, the router is pretty self-maintained. I do have a chiller box, and I've got a debris vacuum. Quickly take a peek at that. It's right there off to the side. I've got actually 3 devices here. First one here, this is the liquid coolant that will help extend the life of your cutting bits. This is a liquid chiller. This is actually cooling the motor that is in the router. And then this device here, this is a debris vacuum. So 1, 2, 3 devices here that we're looking at are for routing and cutting. One of them is optional. So the liquid lubricant device there, that is an optional additional cost. With the 3 kilowatt, you're going to get the chiller and you're going to get the debris vac. That's all included. And then if you're cutting a lot of metal, that's what that lubrication is for. And again, that's bit lubrication. That's going to just extend the life of your bits. So this is a PVC that we're looking at here. We're about 1/4 of an inch thick on this stuff. I think the machine has decided based on the the bit that I've got selected to do multiple passes. Yeah, we're going to do a multiple pass of 0.118. I'm using a 4 mil bit for this, and this is our medium speed profile. So I do have a higher speed profile that can run this faster. This is a medium speed profile running at about 472 inches a minute. So we'll see what this looks like. So first thing I need to do before I start a job is I need to talk about our milling mats. Almost forgot. So milling mats are very important. And you can see underneath of this this job, I do have this milling mat down. And again, that's just to prevent accidents, oopsies like this right here. So this was actually cut into the belt. It is glued and filled. But you want to make sure to put a sacrificial mat down, and then you need to calibrate your machine and tell the machine that this is your new zero position. So I'm going to do that right now. Drive the machine over. I'm going to activate the vacuum underneath of that panel. And then in my software screen, I'm going to hit one button here, very bottom. This is set tabletop reference, and that is going to activate that green measuring foot to come down and zero out the milling mat. So now when I cut to anything, it's going to cut to that zero position. So we'll go ahead and start the job. Find that first registration mark for the machine. So right there is our first registration mark. I'm just going to go ahead and confirm that. Yes, that's where I want it to start looking. And again, the machine is going to measure the thickness, find the rest of those registration marks, and we'll begin cutting. So see that red light? That red light indicates that the router bit is moving and spinning. Flashing means it's getting up to speed. Once that light goes completely solid red, we are at optimal RPM for cutting, and the machine will drop down, as you can see, and begin cutting for us. Here's our second pass. And then we're on to the next shape. Now, general rule of thumb, you don't want to cut deeper than the width of the router blade, router bit. So if you're using a 3mm router bit, you typically don't want to cut deeper than 3mm in a single pass. Now you can do 3mm and then another pass of another 3 to give you a total of 6. While this is cutting, go ahead and switch over, looking at our software. I do want to quickly at least touch on some of the options for routing. We've got different tool offsets, so we've got outside, center, inside, and washout. I've got tool direction of cut path, so I can decide clockwise or counterclockwise. And then right here, I've got multiple passes. So based on the depth that is plugged into this value here, this is how much it's going to chew away at each time. Almost done here. Another nice feature that IPC has a pie chart that's counting down how long it is to complete the job. So you could have this screen here, you can see on the bottom right software screen, up on the main screen of the computer. And that would allow an operator that is doing a second task to see the progress of his cutting job on the table. Maybe that operator is also running a printer and needs to go over and check on the printer. You know, from the the swivel screen that we built into the podium of the machine, he can effectively have that, up on the screen just like that right there, so you can see from across the shop progress of his cut. So as far as what materials the router can and cannot cut, typically we say anything, we can cut anything as long as it's not steel, glass, or ceramic. Those 3 materials are, are better suited for a different type of, cutting, whether it be laser or water jet. Those tend to give a little bit better of a result. There we go. So one thing I like to show, when we route, is the minimal amount of debris that may be left behind. So I'll take the waste off first, so you can kind of see down into the job a little bit right there. And then we'll take a look at some of these cuts. So this is a rounded corner cut here. Very smooth, clean cut. No burrs, no lips, no starting or stop points. Let's look at a straight cut here. There's our straight cut, nice clean corners. Very minimal debris. Look at that. There's like nothing there. I mean, I've got a dusting of debris. Even small parts. I've got something, maybe 4 inches by 8 inches here. Very easy to vacuum down. We've got real strong vacuum. In the X tables, they're equipped with 4 vacuum zones. We'll quickly take a peek at our software screen here. That's what the completed job looks like. But yeah, the vacuum zones, you can see here, if I go to my production tab and I zoom out a little bit, that's my entire table. And you can see here, I've got the bottom right vacuum zone activated. And that's activated because I've got intelligent vacuum control turned on. So it noticed that based on where the reg marks were, the entire job fit within that vacuum frame. So it turned the other 3 vacuum frames off and concentrated that vacuum onto that one individual channel. So we've got an intelligent vacuum control that automatically thinks about the operator and how the machine can optimize the machine automatically to give the operator the best chance possible to get a perfect cut. So we've put a lot of that automation in there as standard things so that the machine is very user-friendly in that respect. Well, I thank you for your time today. We've covered a lot of different materials. I hope I've answered a lot of questions you may have on the machine. My name is Jesse Allmeyer. I work for Kongsberg here in Miamisburg, Ohio. Thank you for your time today, and have a good one.